Scientists have long been fascinated by Mount St. Helens, a dynamic and formidable volcano nestled within the Cascade Range of the Pacific Northwest. Renowned for its devastating eruption on May 18, 1980, this mountain has served as a cornerstone of geological and ecological research. For decades, researchers have meticulously studied its behavior, eruption patterns, and the resilience of the surrounding environment in the aftermath of its catastrophic events. Recently, however, Mount St. Helens has once again captured the scientific community's attention with a discovery that has sparked both intrigue and concern. What researchers uncovered beneath the volcano's surface has unveiled startling new insights and raised urgent questions about its future. The story begins with what seemed like a routine survey, part of the ongoing efforts to monitor the volcano's seismic activity, gas emissions, and topography. These activities are essential not only for advancing scientific knowledge but also for safeguarding the communities that live under the looming threat of this unpredictable giant. Yet, during what was intended to be a standard investigation, scientists stumbled upon one of the most unsettling discoveries in recent geological history. Using advanced ground-penetrating radar and other imaging technologies, the team sought to map the magma chambers and fault lines deep beneath Mount St. Helens. As the data poured in, they observed anomalies that were as perplexing as they were unprecedented, unusual voids and structures that seemed almost unnatural, as though something had been deliberately buried deep below. Initially dismissed as errors or artifacts of the imaging process, the anomalies were eventually confirmed through further analysis. To uncover the nature of these mysterious voids, the team decided to drill into one of them, a decision that would reveal a chilling reality. As the drill penetrated deeper, it released unusual gases that, upon analysis, were found to contain unexpected compounds. Among these was hydrogen fluoride, a rare and highly toxic substance not typically linked to volcanic activity. This discovery has left scientists grappling with its implications, as the presence of such substances points to forces and phenomena previously unrecognized in the study of Mount St. Helens. Although hydrogen fluoride is occasionally found in volcanic emissions, its concentration here was alarmingly high, far exceeding normal levels. This alone was cause for concern, as hydrogen fluoride is not only lethal to humans but also highly destructive to the environment. However, the true shock came when the drill breached the void itself. Inside, researchers encountered a phenomenon that was both bizarre and chilling: crystalline formations that seemed to pulse with energy. Composed of unknown minerals, these formations were entirely unlike anything previously observed in volcanic environments. Even more perplexing, they emitted faint electromagnetic signals that defied explanation, leaving scientists grappling with the implications of their unprecedented discovery. As the team investigated further, they found that the crystalline structures formed an intricate network, spanning vast areas beneath the volcano and linking multiple voids and chambers. These formations reacted to external stimuli, altering their electromagnetic frequency and intensity in response to seismic activity, or even the presence of the researchers themselves. It was as if the crystals were alive, or at least operating under some form of intelligence. This raised unsettling questions. Were these structures the result of an unknown geological process, or did they point to something far more extraordinary, perhaps even extraterrestrial in origin? The scientific community was sharply divided. Some researchers theorized that the formations were products of Mount St. Helens' violent geological history, shaped by unique conditions deep within the Earth. Others argued that their complexity was far too great to be explained by natural processes alone. Samples collected from the site revealed even more astonishing details. Laboratory analysis uncovered isotopes not found on Earth, lending credence to the idea that the crystals might have an extraterrestrial origin. Additionally, the electromagnetic signals emitted by the formations showed patterns resembling coded information, leading some to speculate that they could be a form of communication or data storage. As news of the discovery began to leak, public reactions ranged from fascination to outright fear. Conspiracy theories flourished, with some claiming the crystals were remnants of an ancient alien civilization that had used Mount St. Helens as a base or a signal beacon. Others suggested they were part of a clandestine government experiment gone awry, hidden beneath the volcano to keep them out of sight. Meanwhile, the scientific community focused on the implications of the findings, determined to uncover the truth behind this unprecedented discovery. If the crystals were indeed extraterrestrial in origin, their discovery would revolutionize our understanding of geology and provide humanity's first direct evidence of alien technology on Earth. The implications would be staggering, challenging fundamental assumptions about our place in the universe and raising serious questions about the risks of interacting with such technology. As research progressed, another startling revelation emerged. The crystalline network beneath Mount St. Helens appeared to be expanding. The voids grew larger, and the formations became increasingly complex. Alarmingly, this growth correlated with heightened seismic activity, suggesting a direct link between the crystals and the volcano's behavior. Some scientists feared that the crystals were drawing energy from the magma chamber, potentially destabilizing the volcano and increasing the likelihood of a catastrophic eruption. The prospect of the crystals influencing volcanic activity added a new layer of urgency to the investigation. If their unchecked growth continued, it could trigger an eruption even more devastating than the infamous 1980 event. Such an eruption would not only endanger local communities but also have global consequences. The release of ash and gases into the atmosphere could disrupt weather patterns and agricultural systems for years. In response, government agencies and scientific organizations escalated their efforts to study and contain the phenomenon. Advanced sensors were deployed around Mount St. Helens to monitor the crystals' growth and their impact on the volcano. Data from these sensors confirmed that the electromagnetic signals emitted by the formations were intensifying and becoming increasingly complex, lending further support to the theory that the crystals represented an intelligent or semi-intelligent system. Despite these efforts, many critical questions remain unanswered. What are these crystals, and where did they come from? Are they a natural anomaly, an extraterrestrial artifact, or something even more incomprehensible? Most importantly, what is their purpose? Some researchers have hypothesized that the formations could be part of a dormant system designed to interact with Earth's geology, perhaps for energy harvesting, communication, or some other unknown function. This discovery has sparked a surge of interest in examining other volcanic regions around the globe. Early investigations suggest that Mount St. Helens might not be unique. Similar formations have been detected in other active and dormant volcanoes, hinting at the possibility of a global network. The implications of this phenomenon extend far beyond geology, touching on questions of planetary science, extraterrestrial intelligence, and the profound interconnectedness of Earth's natural systems with forces that may lie far beyond our comprehension. If the crystals are indeed extraterrestrial in origin, they could unlock groundbreaking insights into advanced materials science, energy generation, and even the fundamental nature of intelligence. However, such opportunities come with immense risks. Interacting with a technology that is so poorly understood could have unpredictable and far-reaching consequences, potentially endangering not only the area around Mount St. Helens but the entire planet. As scientists race to uncover the mysteries of the crystals, the world watches with a mix of awe and apprehension. The discovery has opened a new frontier of scientific exploration, one that challenges our understanding of nature and our role in the universe. Whether this leads to unprecedented advancements or catastrophic consequences remains uncertain. What is clear, however, is that the secrets buried beneath Mount St. Helens have permanently reshaped humanity's view of Earth and its future. As the investigation deepened, the scope of research expanded. What began as a localized discovery rapidly grew into a phenomenon with global implications. The crystals' unique properties, combined with their apparent capacity to grow and interact with their environment, drew researchers from diverse scientific fields. Geologists, chemists, physicists, and computer scientists joined forces to analyze the formations and assess the risks they posed. A central mystery revolved around the mechanisms driving the crystals' growth. Laboratory analysis of samples revealed that the formations absorbed trace elements from their surroundings to expand their structure. Even more intriguingly, they appeared to convert thermal and seismic energy into electromagnetic signals that seemed to guide their growth. This suggested the crystals were not passive geological features but active systems with a level of functionality that defied conventional explanation. These findings ignited intense debate within the scientific community. Some researchers argued that the crystals represented an entirely unknown natural process, perhaps a unique type of geological phenomenon linked to volcanic activity. Others pointed out striking similarities between the electromagnetic signals emitted by the crystals and patterns found in advanced communication systems. This fueled speculation that the formations might be artificial in origin, created by an intelligence far more advanced than our own. To test these theories, researchers conducted experiments simulating the extreme conditions within Mount St. Helens. Using advanced modeling techniques, they recreated the high temperature, pressure, and chemical environment of the voids where the crystals were found. When exposed to these conditions, the crystals not only grew but also exhibited adaptive behaviors. For instance, when researchers introduced small amounts of foreign materials, the crystals altered their structure to incorporate these elements. This adaptability hinted at a level of complexity and responsiveness that went beyond anything previously observed in natural systems. The discoveries raised more questions than answers. What drives the crystals' growth and adaptability? Are they the product of unknown geological processes, or do they represent the work of an advanced intelligence? And most critically, what is their purpose? As research continues, the potential implications grow ever more significant. Could these crystals be part of a global phenomenon? Early investigations into other volcanic regions suggest that Mount St. Helens may not be unique. If similar formations exist elsewhere, they could represent a network spanning the planet, one that challenges the boundaries of our understanding and forces humanity to confront its deepest uncertainties. While these experiments shed significant light on the crystalline formations, they also raise troubling concerns. The crystals' apparent ability to adapt to their environment suggested they might pose an even greater threat to the stability of Mount St. Helens than previously understood. By drawing energy from the magma chamber and expanding their structure, the formations were creating additional voids that could destabilize the volcano's already precarious foundation. Given Mount St. Helens' history of devastating eruptions and its status as one of the world's most closely monitored volcanoes, the implications were alarming. The possibility that the crystals could influence volcanic activity prompted immediate action from government agencies and emergency management teams. Evacuation drills were conducted in nearby communities, the volcano's monitoring systems were upgraded, and contingency plans were developed to mitigate the potential fallout of a catastrophic eruption. Discussions also began about whether it might be possible to remove or neutralize the crystals to reduce the risks they posed. However, attempts to interfere with the formations were met with unexpected challenges. Efforts to extract larger samples triggered bursts of electromagnetic energy that disrupted equipment and caused localized outages in radio and satellite transmissions. These events deepened the mystery surrounding the crystals and raised further questions about their nature and purpose. As the investigation progressed, seismic imaging revealed that the voids beneath Mount St. Helens were not isolated. Instead, they were part of an extensive network of tunnels and chambers extending far beyond the volcano itself. These subterranean pathways contained additional crystalline formations, many larger and more complex than the initial discoveries. This vast network suggested that the phenomenon was not unique to Mount St. Helens but part of a much larger system. The discovery prompted scientists to examine other volcanic regions, particularly those in the Pacific Ring of Fire, a geologically active zone known for its volatile volcanoes. Early findings were both exciting and concerning. Anomalies similar to those beneath Mount St. Helens were detected in regions such as Mount Rainier, Mount Shasta, and even Yellowstone. While these formations had not yet been studied in detail, their similarities hinted at a phenomenon of global scale. If the crystals were a natural occurrence, their widespread presence could offer valuable insights into Earth's geological processes. However, if they were artificial in origin, their distribution raised profoundly unsettling questions. Who or what created them? For what purpose? And most importantly, were they still active? To explore these possibilities, researchers turned to historical records and ancient myths. Stories from various cultures described mysterious structures and objects associated with volcanic activity. Some accounts spoke of glowing or pulsating lights emerging from volcanoes, phenomena that could be interpreted as early observations of these crystalline formations. While these accounts were largely anecdotal and steeped in mythology, they hinted at a deeper history of humanity's encounters with the unknown. The implications of these discoveries were staggering. Were the crystals remnants of a forgotten past, evidence of an advanced intelligence, or a natural geological process yet to be understood? And as their presence beneath multiple volcanoes became increasingly evident, scientists and governments around the world faced an urgent question: could humanity afford to leave this mystery unsolved? The discovery of the crystals provided a captivating context for scientific investigation. Meanwhile, public interest in the find grew rapidly, with news outlets worldwide covering the story and social media buzzing with speculation and conspiracy theories. Some believed the crystals were evidence of an ancient alien civilization that had visited Earth, while others suspected they were part of a secret government experiment, possibly linked to advanced energy technologies or defense systems. Still, others interpreted the discovery as a warning of impending catastrophe. The growing attention brought both advantages and challenges. On the positive side, it increased funding and resources for research, enabling scientists to expand their efforts and collaborate across disciplines. On the downside, it created pressure to deliver quick answers, often leading to sensationalized or misleading interpretations of the findings. Managing public expectations became a critical issue as researchers struggled to analyze the complex and sometimes contradictory data. As the investigation entered its second year, a breakthrough was achieved using advanced quantum computing techniques. Researchers decoded some of the electromagnetic signals emitted by the crystals, uncovering astonishing patterns that resembled mathematical equations and algorithms. These intricate patterns, far more complex than anything found in nature, seemed to encode information about the crystal's structure and behavior. This finding provided compelling evidence that the formations were artificial in origin, sparking profound questions about their purpose. Were the crystals a form of communication, a message from an advanced civilization, or a tool designed to interact with Earth's geology? And if so, to what end? While these questions remained unanswered, decoding the signals marked a significant step forward. The crystals' unique properties also presented both opportunities and risks. They showed potential for advanced technologies, including energy generation and data storage, but attempts to harness their energy posed dangers, especially if the crystals were closely linked to volcanic activity. This duality fueled debates within the scientific community. Some researchers advocated for cautious monitoring and containment to minimize risks, while others pushed for bold exploration to unlock the crystal's full potential. This debate highlighted a broader tension between the pursuit of knowledge and the need to protect the planet from unintended consequences. Despite the uncertainties, the discoveries so far have reshaped our understanding of geology, physics, and the potential for intelligent systems in unexpected places. The crystals have raised profound questions about the nature of our planet and humanity's place in the universe. Whether they are a natural phenomenon, an alien artifact, or something even more mysterious, their impact on science and society is undeniable. The journey to uncover the truth is ongoing, with each discovery bringing us closer to understanding the forces shaping our world and the mysteries lying beneath its surface. However, as we delve deeper into the unknown, we must also confront the risks and responsibilities that come with such exploration. The crystals beneath Mount St. Helens have opened the door to a new frontier of knowledge, challenging us to think differently about our planet and our future. What lies on the other side of that door remains uncertain, but one thing is clear: the story of Mount St. Helens is far from over.